Hello and welcome to this course on Matlab programming for numerical computations. We are in the week 12 of this course. This is the final week. In this week, I am going to finish off this course by wrapping up and summarizing what we have done in the previous 11 weeks. I'll also talk about one of the important features of using numerical techniques, which is you can combine multiple numerical techniques in order to solve more and more complex problems and larger problems. The objective of this course was to introduce learners to Matlab for solving computational problems as scientists and engineers. So this was pitched as a lab course. We talked a little bit about the theory behind the numerical methods, the computational techniques, but we primarily focused on how you can use these computational techniques to solve problems. Okay, every time I have talked about what is the overall theoretical basis without actually making any derivation. At multiple locations, I have given links to my other course, which is a numerical methods course. I have given links to that course so that you can view those videos and you can understand the theoretical reasons behind some of the approaches that we have talked. However, this particular course tried to present a practical approach if you wanted to solve numerical problems as scientists and engineers. This course was pitched for both undergraduate and postgraduate levels, okay. And the attempt over here was to pitch it at undergraduate level as well as to give certain things, bonus materials for postgraduates, so that they can find it useful in their research as well as in their projects. So we started off a couple of weeks, in the first 2 weeks, talking about programming using Matlab. We talked about the basic structure of a Matlab code, and I said that it's very useful if we've split the code into 3 parts: the initialization part, the computation part, and display/plotting part. Okay. By doing this, we actually give a very nice structure to the Matlab code that is going to be very beneficial to make improve the readability of the code. We then talked about the importance of thinking in terms of arrays and matrices in Matlab. That's because Matlab naturally works with vectors and arrays and matrices. And hopefully in the last 11 weeks, you might have seen how powerful it is to think in terms of vectors and matrices. We then talked about Matlab functions and script. We showed the difference between Matlab functions and script, and we also talked about how to write codes, how to debug codes, and at various places in the videos, whenever I have made mistakes, I have not deleted those sections of the videos. What I have done is I have retained all the errors so that you can see how you can go back and try to correct the errors. Debugging of a code is a very important skill, and that was the reason why I have retained the errors that I have made in the videos. We also talked about how to use these parameter structures in order to pass on the parameters to the functions. Okay. Throughout this course, we have sometimes did not pass the parameters to the function but included parameters within the function itself. Sometimes we have passed the parameters to the function using structures. The reason for following both these approaches is so that you can learn that both these options are possible, and you will find with experience one of the two approaches is more suitable for you. And that's the approach that you need to take. You need to take an approach that is most suitable for you rather than prescribing one versus the other approach. Okay. Personally, me as well as my students, we use the approach where we define all of the parameters together in one place and pass on the parameters to the various function using the parameter structure. Okay. But finally, it's really up to you which method you find more appropriate for your application is the method that you need to follow. Okay. Then in the week 3, we talked about fundamentals of computational techniques. We talked about machine precision, which is nothing but the least count of a machine. For Matlab in the current generation machines, that machine precision is 10 to the power minus 16. And what that means and how we can use that and how it affects the overall error analysis, we saw in the rest of the videos. Okay. We talked about direct versus multi-step versus iterative approach. Direct example of direct approach is something like a Gauss elimination. Multi-step approach is something like Rangekutta method, where you start with time 0, then time 1, time 2, time 3, time 4, and you progress in time. Iterative methods, or things like Newton-Raphson's, where you keep iterating until you reach the final solution. Okay. We also talked about the sources of errors and how error propagates and why an understanding of this is important. Thereafter, from week 4 to week 11, we solved various different problems. Week 4, we solved linear equations. Linear equations were of the nature Ax equal to b was linear equations. Non-linear equations were of the nature fx equal to 0. Okay. Of course, if you look at the first equation, you can always write it as ax minus b equal to 0, and that gets the form fx equal to 0, and you can solve that. Of course, that is going to be an overkill. The right way to solve these equations is x equal to a backslash b, or okay. For solving fx equal to 0, we used f0 for single variable problems, or fsolve for multiple variable problems. Okay. We also talked about differentiation and integration, numerical differentiation and numerical integration, where we talked about central difference and forward difference and backward difference formula, and we also talked about how errors are affected in all of these methods. Okay. We also said that for central difference formula, epsilon to the power 1 by 3, which is approximately 10 to the power minus 6, is the best step size. For forward and backward difference formula, epsilon to the power half, which is approximately 10 to the power minus 8, is the best step size. We then talked about curve fitting, so we talked about regression and interpolation. Okay. This was done in week 9 of the modified course. Differential algebraic equations, we talked about ODE, IVP in single variable in week 7, and multiple variables week 8, including stiff system of ODEs. Okay. In week 10, we talked about ODE boundary value problem, and in week 11, we talked about PDEs. Okay. One of the things that I plan to cover for postgraduate students, that was in week 10 bonus, that was DAEs. Why was it given as bonus and not a regular lecture material? It was given as bonus because a lot of undergraduate programs do not cover DAEs, so it becomes a little bit of an advanced concept for undergraduates, and about 2/3 of the students in this course are undergraduates, and therefore the DAEs was covered as bonus lectures. Okay. So these were the various kinds of problems that we solved. Okay. As I said in the starting of this video, the true power of numerical approach is to solve large or complex problems, and most of the times when you are solving large or complex problems, you combine multiple different numerical techniques in order to solve that problem. Okay. That is what we are going to show in the next video. In the next video, what we are going to show is how you have already used, in some of you may not have even realized it, but you have already used combination of multiple techniques in order to solve numerical problems, and thereafter we are going to take a few examples where we will show you how you can combine different numerical methods in order to solve various problems. That is going to be our game plan in the rest of this week. Okay. So with that, I come to the end of this video. I hope you have enjoyed this journey with me, and this is the final week, and I hope this culminates into something that you find extremely useful in your future careers. Okay. So thanks for watching, and bye.